Okay, so let's start going through paper 1, Physics Trilogy Foundation paper. This is the specimen paper that was released in 2018. Okay, so question 1 looks like it's about electricity. Most electrical appliances are connected to the mains using 3 core cables. What is the approximate value of the potential difference in the UK mains electricity supply? Tick 1 box. So usually you pick up any electrical device and somewhere on it there'll be a label and it will tell you the answer to this. And if you have a look, in the UK we're at 230 volts. In America they're at 110. So you get adapters when you go on holiday and things like this. Okay, figure 1 shows a 3-core cable, and they've labelled the live one, and there's 2 others to be labelled. Right. So what do we get in this cable? The stripy one is the earth cable. Live cable is brown, and the blue cable is negative. Okay, so I have a bit of a funny, rude way of remembering that the brown cable is the live wire, because if you touch it...
How do you switch it on?
It's just that little lever there.
This one here?
Anyway. Okay, so in the UK, the 3 wires in a 3-core cable are always the same colours. Why are they always the same colours? Tick 1 box. Again, exam technique. Always, whenever they tell you tick 1 box or tick 2 boxes, just eliminate the ones which are stupid and then guess from what's left. So each wire is made by a different company. That would mean every single one is a different colour, if that's the reason. It's easy to identify each wire. That seems like a sensible option. They're cheaper to manufacture in different colours. Again, doesn't really make sense. So it's so that you can identify them, so that when you're going through the house at different places, you find a wire, you can identify whether it's the live wire, the earth wire, etc. Touching the live wire is dangerous. Use answers from the box to complete the sentences. So, touching the wire causes a large potential difference to exist across the body, and this causes... Okay, so when you have a large potential difference, a large potential energy difference. So an example of that might be, you've got a load of water in here, and they've got a hole at the bottom here. And if you've got lots of water inside here, the water has potential energy, and on this side, if the water could get to this side, out here, it would have less potential energy. So if you connect up to vessels and one has no water in it, and we have like a tap or something here, as soon as you open this tap, the water is going to go gushing across because there is a potential energy difference per litre of water. So potential difference will cause the water to move, which we call current, and in electricity we call it current as well. So we get a current flowing through the body, which results in an electric shock. Okay, again they've given us the words, so we used this word, we used this word. This is nothing to do with this topic. I suppose they were testing to see if you understood what potential difference meant by putting voltage here, because if you didn't know they basically mean the same thing, that would have been that could have thrown you off. And resistance is the thing that slows down current or reduces current flow. Okay, what is the approximate frequency of mains electricity supply? Right, so if you've ever bought computer games or things from abroad, they can either be 60 Hertz or 50 Hertz. UK we have 50 Hertz electricity supply, which means that the current changes direction, goes one way, then the other, 50 times a second. 50 Hertz is that's what it means. So if you could look at it on a oscilloscope trace, and this was current and this is time, you would see that it goes, it varies 50 times a second like that. Okay, figure 2 shows how power stations transfer electrical power to consumers using the national grid. The power station generates electricity at a voltage of 25 kilovolts. 25 kilovolts. Just better point out, as soon as you come across anything with a prefix like this, it's worth noting or making a mark on it, because at some point in the paper they're going to ask you to do some kind of conversion, I'm guessing. Transformer A increases the voltage by a factor of 16. What is the output of transformer A? Right. An output of 16, a factor of 16, sorry, what's the output of transformer A? So we're looking at this transformer here, and it increases the voltage by a factor of 16. The voltage comes out of the power station at 25 kilovolts. It goes into the transformer, and it's increased by a factor, times by a factor of 16. That's what it simply means. So I need to do 25 times 16. I've just noticed here that actually I don't need to do the conversion because the unit is already converted, so no worries there. 25 times 16 on the calculator I brought with me. 25 times 16, 400. 400 kilovolts. 400 kilovolts is what's travelling along. Kilovolts is what's those cables are carrying. Now, why is the voltage increased by transformer A? Okay, so the analogy to help you understand this is, imagine you want to send your day's takings from your shop, right, to the bank. Say it's the bank, got bars in it because it's a bank. All right. You can either send 100 cars, each with £1 in. Let's say you made £100 that day. You can send 100 cars with each carrying £1, right? And that way you'd have a hell of a lot of traffic. You'd get a lot of congestion on the roads. Or you could send one car with £100, right? And that would be a lot less traffic. So essentially, when you're sending energy via the national grid, if you can send it at a very high voltage, it's the equivalent of you have less current, basically, and less current means you get less heating effect in the wire, because as current flows through the wire, it actually heats the wire up.
Now this time we've got a new piece of cable, and this should be around 100 amps, so just to connect on. So 150 amps or so there, and you see the temperature's climbing rapidly on the temperature gauge. Smoke is already billowing out of the wires, and of course the cable is now totally destroyed.
So we do this to reduce energy loss by heating. Okay, why is it important that the voltage is decreased by transformer B? It's a safety issue, to make things safer for consumers. Okay, if you found this useful, please comment, like and share. Thanks for watching.